everyone, Katrina here, and welcome to the Factoring Crash Course. Today you will learn everything you need to know to factor quadratic equations fast. This course will start by going through difference of squares, then perfect square trinomials, afterwards factoring with product and sum rule, and finally learning how to factor with the quadratic equation. Let's dive in. Let's start by considering a function that has the following form: x squared minus a squared. This is a difference of squares, and this factors easily to x plus a multiplied by x minus a. The trick for this one is first to determine if you have two perfect squares that are then separated by a minus sign. If that is the case, then this will factor perfectly every single time. Let's look at an example to clear this up. What if we have x squared minus 81? The first thing we have to ask ourselves is, do we have two perfect squares? We see that x squared is a perfect square. And what about 81? 81 is the same as 9 squared. Therefore, in this case, we have two perfect squares, and like we just mentioned, they are separated by a subtraction. Therefore, this is a difference of square, and now we can follow the same template to factor this. Therefore, in factored form, we have x plus a, which is 9 in this case, multiplied by x minus 9. And there you go, it's all factored. Let's look at one other example just to make sure we have this. What if we have a coefficient in front of our x squared? Let's see what happens then. What if we have 25 x squared minus 4? In this case, we can identify that 25, x squared, and 4 are all perfect squares, because this can be rewritten as 5 squared times x squared minus 2 squared. Now we're going to follow our same structure and factor this. So now we have 5x minus 2 multiplied by 5x plus 2. Just so you know, it doesn't matter whether you have the negative first or the positive first, because multiplication here is commutative, meaning that order doesn't matter, just as long as you break up this difference of squares into the first term minus the second multiplied by the first term plus the second, or vice versa. Okay, now that we've mastered this skill, let's move on and look at a perfect square trinomial. Okay, so we're going to do a perfect square trinomial. Let's look at a format. We're going to have x squared plus or minus bx plus c. Now this is our generic expression for a quadratic equation. We have a trinomial in this case because we have three different terms. So what makes a perfect square trinomial a perfect square trinomial? Let's take a peek at that. So in order for a perfect square trinomial to exist, our b value, if we take our b value, this guy over here, and divide it by 2, and then square this whole piece, if this whole term over here equals to our c, then we have a perfect square trinomial. Let's look at an example to clear that up. Say we have x squared plus 10x plus 25. Let's check to see if this gives us a perfect square trinomial. So our b value equals to 10. So let's start by taking 10 divided by 2. That equals to 5. And now let's square this term. 5 squared equals to 25. So that means that this, in fact, is a perfect square trinomial. So now you might be wondering, well, how do we factor this? Why is it special to have a perfect square trinomial? And let me show you that. So perfect square trinomials factor in this form. You end up having x plus or minus b divided by 2 all squared. In one step, we have this trinomial perfectly factored. So let's take a look at what that means for our example here. So here we have that our b value equals to 10, and b divided by 2 equals to 5. So that means that our example here is simply going to factor into x plus 5 all squared. Now where does this minus come in? So say if instead we had a subtraction for our first term over here, then instead of having x plus 5 squared, we would have x minus 5 squared. But just be aware that the final constant always has to be positive in order for it to be a perfect square trinomial. So again, the first term here can be plus or minus, but the second one has to be positive to be a perfect square trinomial. Okay, very good. So those are our two quick and easy tricks, the difference of square and perfect square trinomial. Now we're going to learn something new that's more applicable to more quadratics. This is called the product sum rule. So let's see what that looks like. So let's get a generic polynomial again, a quadratic here. So we have ax squared plus bx plus c. This is what we're going to be looking at a lot here. So let's figure out what is another way to factor this if it doesn't fall in the earlier two categories. So what we have to do here is we have to look at the product of our a and c value. So you want to take the product of those values, and then we want to look at our b value to determine a sum. Okay, what does that mean? Let's look at an example. So say we have x squared plus 3x minus 4. So this is going to be our example here. We're going to look at an easier case first, but stick around because I'm going to show you a more difficult case afterwards. So for this first case, we see that our leading coefficient equals to 1. So we have just a 1 in front of our x over there, nothing else going on. So that means that when we take the product of 1 times our c value here, which is -4, we get -4. So let's write that on the side. So here our product equals to 1 times 4, which equals to 4. And then we are looking at our other b value over here, our b value, which is our sum value, and that equals to 3. So now, true to its names, we want to find a number. Oh, I'm sorry. This should be a -4 because it's 1 times -4. So true to their names, we have to now determine what are two numbers that multiply to -4 and add to 3. So let's take a little zoom in over here and look at all the factors of -4. So in this case, we have 1 and -4. We also have 2 and -2, and then we have -1 and 4, and -2 and 2. So can we find a sum from any of these numbers that equal to 3? So 1 minus 4, that doesn't work. 2 minus 2, that doesn't work. But -1 plus 4, this works right over here. That means that we can use these two numbers to help us factor our problem. So let's take a look at our big picture again. So the fact that our leading coefficient equals to 1, so I'll write that again, our leading coefficient equals to 1, that means we can dive into the next step right away. So we're going to take our two numbers that we found here and split up our trinomial into two terms, such that we have x minus 1 multiplied by x plus 4. And you can see that this is our first number from over here, and then this is our second number also from over here. And that's it. It's factored. Wasn't that nice and easy? So now we're going to look at one other case where our leading coefficient, where our a does not equal to 1. So let's look at an example there. And it's not too bad. There's just one extra step we have to consider. So let's look at this example. What if we have 2x squared plus 7x plus 3? So the first thing that we want to consider here is our leading coefficient. Our leading coefficient equals to 2. So leading coefficient equals to 2. It does not equal to 1, so we have to do an extra step here. Okay, so let's look at our product and sum rules. So our product here is 2 times 3. So we have 2 times 3, which equals to 6. And our sum value equals to 7. So now we have to do the same exercise we did previously, and we need to look for two numbers which multiply to 6 and add to 7. So let's look again at the factors of 6. So we have 1 and 6, we have 2 and 3, we have -1 and -6, and -2 and -3. So right away, we can see that 1 plus 6 equals to 7. So we already found our two numbers that we can use. This time, however, since we have a leading coefficient that does not equal to 1, now instead what we have to do is we have to separate this middle term into our -1x, oh sorry, not -1, just 1x, into 1x, which is just x, and to our 6x. So these are our two values that we found from over here. And let's do the next step. So we rewrite this by dividing the middle term into these two new parts. So we just have 2x squared plus x plus 6x plus 3. And this is where the trick comes in. Now what we have to do is just put brackets around our first two terms and our second two terms and see what can we factor out. So from the first term, we can factor out an x, and that leaves us with 2x plus 1. From our second term, we can factor out a 3, which leaves us with 2x plus 1. You know that you have done this correctly if this number in the first brackets equals the number in the second brackets, because that means you can factor out that whole term. Watch this. Now we're going to factor out this 2x plus 1, and then all we have left is just the value in front here and the value in front there. So we have 2x plus 1 times x plus 3. And there you have it. It's all factored. So just to recap for these product sum rules, if you have a leading coefficient, an a value that does not equal to 1, you still find the product and sum, but you have to use those values to split up your middle term, and then you have to factor kind of each side separately. However, if we had the other case where our leading coefficient equals to 1, then you just take whatever you found from your product sum rule and stick it right into factored form. So it's just one less step. Okay, so now we're going to look at another case, our last case for today for the crash course, and say, what if none of these rules work? Let's consider an example where we have 3x squared plus 8x minus 7. and I want you to go through everything we talked about today. First of all, is it a difference of square? Well, I already see 3 terms. This is a trinomial, so it cannot be a difference of square. Okay, let's check if it's a perfect square trinomial. What was our trick for that? Well, we already have a leading coefficient here. Our other trick was if we can divide this middle term in half and square it, and it equals our final term, then it's a perfect square trinomial. So let's take a little peek to see if that works. So first of all, let's factor out the 3 so we can see x by itself. So we have x squared plus 8 over 3x minus 7 over 3. Okay, let's see if I take this number and divide it by 2, I get 8 over 3 times 2, which is 8 over 6, which simplifies to 4 over 3. And now let's square this value, which equals to 16 over 9. Does 16 over 9 equal to negative 7 over 3? Nope, it does not. So this is not a perfect square trinomial. The other giveaway here is that we have a negative for our last term. And we already said that we cannot have a perfect square trinomial if our last constant term is negative. Okay, these two don't work. Let's try the product sum rule and see if that works in this case. So we have a leading coefficient of 3, so we have to use our second strategy. Let's look. Our product equals to 3 times negative 7, which equals to negative 21, and our sum equals to 8. Can we find 2 numbers that multiply to negative 21 and add to 8? So let's go through the factors. So we have negative 1 and 21. We also have negative 3 and 7. Let's do the other way. So we'd have 1 and negative 21, 3 and negative 7. Do any of these numbers add to 8? They do not. So we cannot use our product sum rule either. So what can we do? This is where we have to use what's called the quadratic formula. So this is the equation for the formula. So x, 1 and 2, so your 2x values equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now let's plug in the numbers from our equation into this. So in our example, we have 3x squared plus 8x minus 7. So this is our a, this is our b, and this is the whole thing with the negative is our c. So what do we get here? We get negative 8 plus or minus the square root of 8 squared minus 4 times 3 times negative 7 all over 2 times 3. So let's see how we can simplify this. So we have negative 8 plus or minus 64 minus 4 times 3, which equals to 12, multiplied by negative 7, which equals to 84. And since we have 2 negatives here, this becomes a positive. So we have 64 plus 84. So therefore, and then we divide this by 6. So let's simplify this even further. So we have negative 8 plus or minus root of 148 all over 6. Now we have to figure out how can we put this into factored form. So the generic form for factored form is x minus x1 multiplied by x minus x2. So using the quadratic formula here, we have our x1 and our x2 values, so we just simply plug that into here. So that means that our final answer is going to be x minus negative 8 plus root 148 over 6 multiplied by x minus negative 8 minus root 148 over 6. And there you have it. It's all factored. I hope this course helped you. We went through all the different ways how we can factor quadratic equations. So now you have foolproof and fast methods to solve any problem on any exam. If you'd like to see more problems, please comment them below in the video. If you like the video, please like it and subscribe for more amazing, engaging, and fun math videos that will leave you wanting more and diving into the math world even further. That's it for today, and I hope to see you next time.